Okay, for people joining our live stream, this is looking at computational chemistry for the upcoming version of Wolfram Language. And I don't even know what serial number of meetings this is, but it's lots, but we're close to the end, I hope. Okay, so what do I do here? Do I need the packlet install?
Yes.
That whole initial cell? Okay, so atom coordinates is an option, or that's an option. Is that correct?
It's an option for molecule.
Atom count is a function. Atom list is a function. Is this bad?
It doesn't look good. Don't.
Well, some things changed color, but others did not.
Right. So I mean that would seem good.
Would you like me to go to the prototype build?
No, I think it should work.
Shall I run this again?
Yeah. But if that is unable to connect to the Packlet server, then you should switch to the prototype build, and it should be fine.
Okay.
Oh, actually.
Okay, it worked.
Yeah, great.
Okay, so first thing, I really like the idea of changing this to be chemical bond for all of our chemical bonds. In which case that should become chemical bond Q.
Okay,
right?
noted. Yeah.
A chemical bond count, chemical bond list. Makes sense?
Yes.
So is there any notion of an automatic bond where it knows whether it's single or double?
So let's see. So if you put it in a molecule, the idea is that it would we would default to single, and then if you added in a pattern, if you omitted the second argument, we would take it to mean any kind of bond.
I see.
Bob and we are interested in introducing an automatic bond order assignment so that you can read in files produced by by electronic structure software where they don't even care about the bonds. That's a problem we need to solve.
Right. Okay. So wait a minute. So there's this two different cases of the any bond or the default bond.
Right. That does seem a bit confusing. But it seems like it would be useful for people when they're typing in a molecule to not have to enter the second argument of the string for it to default to single.
Well, okay, but then maybe it canonicalizes to single.
Yes, and yeah, definitely.
Okay. I mean, I guess that's okay, that the default meaning on entry could be automatic for a pattern and single for a molecule. I mean, are there cases in which it's totally obvious from the structure of the molecule that it has to be a double bond?
Yeah, absolutely.
Not without assumptions, usually.
Well, if you have the coordinates, it can be quite. So if assumptions that there are no implicit hydrogens like that, then
if all the atoms were present and there were two carbons that only had two other ligands besides the each other, then it would be a double bond.
Okay.
But it's not completely obvious, so it's let's see, it's not going to be trivial to implement that.
Yeah. Okay. Yeah, that name is horrifying. Okay, so you have a proposal. Wow. Okay. Molecule substructure indices. Well, certainly having something more specific is a good idea. A nested list of indices of the atoms that match PAT. Okay, so this is in the adenosine molecule. Where are the nitrogens? By the way, I assume that if I put in there the fully decorated, entity nitrogen, it would work.
It should. I do not know that I have hooked that up. If you enter it in a molecule, it definitely does.
Okay, fine. I'm just saying. Let's make sure it does. But okay.
because that's the thing with these the molecule patterns is I have to hook everything up manually because I'm creating an internal structure. So I'm
Yeah,
trying
I
to make it
understand.
match our pattern language, but
Okay. Okay. So this is returning. Why don't you call this molecule substructure positions? Or are they indices? What are those things?
so
Okay, how do I get back out? Okay, so this is ay 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 ay. Oi oi oi, what the heck is this?
so
No. No. I mean, this is the look. I mean, we could have a fully decorated molecule substructure extract. Right? For now, that does this. If what you're doing is you're filling in one of these lists, right? So you're filling in a list like this. It's an extract function, yes?
yes.
So that is not a list of 3 parts. No, I know I'm totally confused. This is a list. I see. That's not a part specification. That's an index list.
Yes. So there are 2 parts of the adenosine that match that are 5-membered rings.
Yeah.
And that's the spec for each of those.
Okay. So wait a minute. So the question is, we want a function. Okay, hold on. So what is this now? Proposal 2, which is different from this one.
Right. So it would be a more versatile function that could that wouldn't just return the atom indices. You could also tell it you want it to return the list of bonds that match the pattern, or the list of atom objects that match the pattern.
I see, but that would be a third argument that would specify that.
Exactly.
Well, I like that idea, actually. I mean, we can implement that and just not support a third argument yet, if we're not ready for that.
It shouldn't be too difficult.
Okay, so then it would be atom indices. Atoms would just be nitrogen, nitrogen, carbon, whatever, right?
Right. So that could also be entities if you wanted to return entities for the atoms.
Yeah, atom entities. Or what are you saying? You're saying the atoms could be entities that are returned by default.
Right. Or I was saying it would be another string there to return element entities.
Yeah, okay. But a different string other than atom indices, right?
Right.
Yes, I think this is a good design. Molecule substructure.
Jason, how about getting both atom indices and bond indices? Or would this third argument be a list of types?
I think it should be allowed to be a list of types.
Okay.
Yeah, I don't think that would conflict with anything.
Would they come back as just plain lists or as an association with keys so you know what's what? I think with an association with keys would make things very clear for the user what they're getting.
I kind of agree. It's a little bit weird, but I kind of agree. Okay, so wait a minute. Molecule substructure. We got weird background noise, by the way. Molecule. Is it the case that what this should actually be called? I mean, normally it would be molecule substructure. couldn't we just call it molecule substructure? And it says it finds the substructure that is compatible with pattern.
But to me, that feels like it should return something that is either a molecule. So to me, it seems like it should return a molecule fragment, which I haven't quite implemented yet.
Right, but shouldn't it return basically this?
Right, so that's what molecule substructure would return.
On its own, right. So then that would be the default case. And if you wanted to get the atom indices, you would say comma atom indices. That would get you the naked atom indices. But the default would be just return me, if I want these aromatic rings or whatever they are, five-membered rings, what I would say is molecule substructure of adenosine, comma molecule pattern this, and then I would get back all the five-membered rings in adenosine, which seems rather nice.
Yeah, I like that.
Okay. So that gets around us having to do all of this stuff here, because if we had a way to specify in molecule substructure, if that pattern, instead of being a molecule pattern, was a naked collection of atom indices, see what I'm saying? Then we could get away with them. Then that would kill two molecules with one stone, so to speak. Did that make any sense?
Yeah, no, this is definitely clear.
H new instead of a stone. Photochemistry.
Yes. H bar omega in my world. Do people really use H in chemistry?
Time.
What? No, H, lowercase h.
I mean, so there's H and H bar are both
okay.
useful.
Yeah.
And in physics, it's almost always H bar.
In chemistry, it's almost always H.
Huh.
Unless you're a theoretical physical chemist and you go.
Yeah.
Right.
Yeah,
okay.
Then it's H bar. Anyway.
Okay.
But we set them all equal to 1 when we start anyway, so.
Yeah, you can't have both H and H bar equal to 1, then you have trouble. Okay, in any case, all right. So basically the idea would be this is the extractor, and then molecule substructure of that, and then this, by default, if you just give a bunch of naked, you could extract the particular bond, you could extract, so this would extract that singleton object like this, molecule fragment like that. This would extract multiple molecule fragments, yes?
Exactly.
Okay, all right, good. Nice. Molecule substructure I like very much. That seems like a very useful thing. All right, what's next?
So in the list of symbols up at the top, the ones in blue are the ones that we have not touched on in detail in these meetings.
What is molecule value again?
It's the property accessor function.
Oh, right. So things like entity value, the analog of entity value.
Right. And it's
so canonical bond we've talked about connected molecule components.
So can we talk about molecule equal next?
So I have sections for those down at the.
All right. Okay. Fine. Let's go ahead.
Let's go with
molecule contains Q. Is that's a tester for molecule substructure?
Exactly.
Okay.
So we want to call it molecule substructure Q now?
I like the contains Q.
Yeah, I think contains is fine.
Okay.
And all it would say in this case is, yes, it's got a 5-membered ring. Be happy.
Yes.
Okay. So modify molecule, is that still on the table?
Right. We let's see. We design modify molecule so as to avoid having 10 or 12 new symbols to. I'm kind of joking there a little bit, but there are a whole different host of ways to modify a molecule and so that function.
Okay. All right.
the
So
umbrella.
down here, modify molecule. Oh my gosh, my gosh, my gosh. So let's look at the syntax for one of these things. Molecule modify, add atom. So those become free floating atoms somewhere, is that right?
Right, and there's an option to turn off adding extra hydrogens. But by
I
default,
include hydrogens arrow true or false.
well, so in this case, yeah, I could hook it up to include hydrogens. In this case, I'm calling it at the moment, let's see, fixed valence.
I would just do include hydrogens. I think it's, or we might want to generalize the name include hydrogens slightly if we don't like that.
Right, I'll look at that and talk more with Bob, and then we'll try and come to an agreement on that.
Right. Okay. Hey, just a random question. How is the discussion about the interactive editor going?
So let's see. So the amount of JavaScript that I need in order to really make it a polished Wolfram Language product is I would need to learn some more JavaScript in order to do that properly.
But what about our friends, the Emerald folk? Aren't they prepared to do that?
I think to a certain extent.
So you should push them on that, because I think they will be prepared to do it, and they have people who know that stuff. You really should encourage them to do it and see whether we can't get something, if not for 12.0, for the 12.0 time frame, not too long thereafter. You should point out the time frames.
Okay, yeah, I'll get back in touch with them.
Please do, because I think this is something they can do, and they want it. So it's a win for everybody. Okay. All right. So this just randomly adds atoms. Is that correct? So if I say molecule M equals that molecule, what the heck happened there?
Okay. So apparently, let's see. So you can erase that and write a molecule, the string caffeine, and it will.
Okay.
So I recently moved everything from one context back.
Oh, I see.
And we see that summary boxes actually hide some stuff that we don't.
What do I want to do?
Well, that has me confused. Maybe quit the kernel.
Something went wrong here. Okay, who knows why? That looks nice. It looks better than it did before, actually.
I think, Stephen, you deleted the quit that was up there in loading. It required a quit, but you removed it.
Ah, I see. Okay. Okay, so modify molecule. I wonder if this is the right form. Modify molecule, whether it should be some kind of molecule change. Molecule modify, I don't know. Seems kind of silly. Add atom. Okay, so let's say I add a tungsten to this thing. Okay, so I've got a random little tungsten hanging out there. So, okay, so let's take a look at what some of these others are.
So now you could add a bond from that tungsten to, say, a carbon.
How would I do that?
So then modify molecule %.
Yeah.
And
Comma,
then,
add bond.
mm-hmm.
Then what?
And then we can use the tooltips to figure out what the proper indices are.
25. Okay, so what do I do? So I say
Single
chemical bond.
So I have.
You haven't done that yet.
Right. Single bond 25, and then I would pick one of those.
Is it like this?
No. So it's just 2 arguments of indices. Chemical bond will have a list as the first argument.
Good, because that's better. I've wanted that for a while. 25 comma, what would I do? 3 or something. Where can I put it on?
So 2 looked good. So you want to pick something that has an extra hydrogen that it could just lose.
Okay, so now I could say something like molecule plot. Molecule plot 3D, just to be more jolly.
Right.
Why?
We can't atom type for tungsten.
What do you mean?
So the embedding code wants to have an atom type to categorize every atom that's in there, and tungsten isn't one of the supported atoms. Generally,
because we don't know the physics of it, or what?
Right.
So which atoms do we know? That error message is unhelpful.
Right.
Okay, so say why it's failing. I mean, because we don't support tungsten.
Right.
Cannot compute molecular structure for tungsten. If that's why it's failing, say that's why it's failing. Is it?
Yes.
Okay.
So I have worked on a method that would use. So you can get a pretty decent structure if you just take the graph of that, make a graph 3D of it using spring embedding, and then use the molecule machinery to kind of make that a better structure. But it's not reliable enough for it to be released yet.
Okay, well, fine. But so for now, just say contains a molecule we don't know how to deal with. Right? Make sense?
Yeah, I'm making a note now.
Okay. All right. So oh boy. Okay, so delete atom 3 or something would just do the right thing.
Right, and it will also delete any dangling hydrogens.
What the hell is that? That seems weird. I mean, I thought that was to be a redox reaction or some weird thing like that of transformation. This means a transformation. No, I'm totally confused.
So it means a geometric transformation.
Well, I don't understand even what that could possibly mean.
So it applies the transformation to the coordinates.
Yeah, you're trying to dock a molecule, for example, into an active site of an enzyme, and you want to move it from one place to another.
So wait a second. So you're saying that this is taking the 3D geometry of the molecule and simply moving it in space. Is that correct?
Well, in that case, we did a scaling transform. I chose an odd transform just to...
Okay, fine. But so there's an issue here. You know, you don't have the 3D geometry of the molecule. How, in other words, I might want, all you're giving me is the molecule plot, the graphics. By the way, you got a bunch of background noise. Could we cut it out, please? You see what I'm saying? We don't have a function which gives the geometry of the molecule, do we? I mean, we can say graph of a molecule. If I say for this, for example, if I say graph of that, then I will get the graph, won't I? No, I thought we were going to get the graph from this.
So it was, let's see, so %7 is graphics, right? But
I see.
If it were a molecule, you'd need to do...
But no. Oh, wait a second. Okay, so you're saying if I get the molecule here, right, then can I say graph of that?
You need to use molecule graph.
What is molecule graph? I thought we agreed we were going to have a graph function. Do we still have molecule graph?
Right. It doesn't seem right to give graph an option of...
Fair enough. Okay, so that was one of our functions from up top here. Yes, it was. Good. Okay, so is it the case that we should have molecule geometry as well?
So right now you can access the geometry through the molecule value or through a sub-value, just atom coordinates. You get the coordinates out. In a graph, you use the function graph.
Why did that not work?
So when you convert a graph that has an edge rendering function into a graph 3D, I think that is what happens.
Is that a problem with the graph functionality? Roger, maybe you can speak to that. Roger? Is Roger
Hello.
here?
Yeah, Charles. Charles is here.
What is
Right.
this?
Right, so it have shape function. We respect the shape function given by the user. So
But it shouldn't give a pink box. It should either give a message or it should do something, right? But a pink box is not a good answer, right? A pink box with a dollar failed thing isn't a good answer. Make sense?
So I can meet with Charles to see how I could design the molecule graph so that when you make a graph 3D of it,
Yeah, since you just told me that making a graph 3D is the El Cheapo way to add random atoms, right? Yeah, I mean, this should work. There's a bug in the graph stuff that this is causing it to say failed and anything. That should not be possible to get from this. Do you agree, Charles?
in principle, no. I mean, we cannot verify the result of a shape function that it be a valid object to render.
I see what you're saying. I see. Well, okay, so then it's more for this case, it's more for the case of Jason coming up with something more reasonable for this. Okay.
I can find some kind of shape function that works in.
Okay, so what I want to know is, does molecule geometry make any sense?
What would you expect it to be?
I'm not certain. But I mean, this, by the time you're doing the scaling transform, what is it transforming there?
So type M and then the subvalue atom.
The only thing you're transforming is atom coordinates, I assume?
Yes.
Or do you always just dealing with points, basically?
Yeah, definitely.
Yeah, I think what this should say is, I mean, this should, applied transformation is definitely not the right name. It might be something like transform coordinates would be better. See what I'm saying?
Yeah.
I think it's a better name, but it does,
I'm okay with this, actually, now that I understand what it is. If we call it like applied transform coordinates or transform atom coordinates would be an easy, then we really know what we're doing. Make sense?
Yes, applied transform is you're right, it's too vague. And you first thought it was doing a chemical reaction type of transformation.
Yeah.
So specifically saying geometry or atom coordinates is needed.
Okay. All right. I mean, I'm not even sure. Why isn't it applying an arbitrary function to that? Is that what this is doing? A scaling transform on what? I don't even know what the scaling transform does to something like just a coordinate vector. Yeah, okay. So it just is applying a function. Right. So there's an arbitrary function that you give there, right?
See, so
yes?
I have it. Let's see. Yeah. I just apply the function to the atom coordinates.
Right. Okay. So let's keep going. Add atom. Okay. Delete atom. Okay. Next up, replace atom.
Perhaps this should be replace part.
I'm sorry?
Perhaps this should be replace part. Since
Why?
specifically looking at indices.
Well, not if you say delete atom is working the same way.
Right,
Delete atom works with indices as well. Right?
Yes.
I mean, somewhat confusingly, add atom just adds an atom floating in the soup. Whereas replace is an index-based thing. I think it's okay. I think that's okay. Add bond versus add chemical bond, I'm not sure. So let's just look at what add bond does. Okay, so that just adds a random bond. Do you think add is the right word? I mean, this thing that just puts something into the soup.
So Jose had once suggested append, since you're just adding it onto the end.
Yeah, I don't think that's right either. But I mean, the fact is that add, Add bond. I guess it's okay because it can be connected to the thing. All right, okay, fine. Okay, canonicalize.
So what we're doing here
So
is,
wait a minute. So wait. Are you saying there's a curried form of modified molecule?
yes.
Okay, if there's a curried form, you better not have 3 argument cases here. Right? This is not a good idea then. Then what you want to do is add atom, arrow, whatever. Right? Otherwise you're going to have ambiguity in the curried form. Oh, I'm sorry. What am I saying? What am I saying? Nonsense. So it's always the case that you have an action and a payload, right?
Yes. Although sometimes the payload is null because when it's
Okay, but this is not yeah, Sandra on our live stream is pointing out there's edge add and vertex add, so it makes sense to have atom add, except that it's called add atom.
right. And I mean, the reason that we have edge add and vertex add, I believe that a previous package had used add edge and add vertex.
That's not the reason.
Okay.
Charles, can you speak to that, please? Charles?
No. I mean,
Well, you named those functions. You named edge add, etc. Right?
Right.
Okay,
so
I think we generally have a bunch of operations that start with edge or they start with vertex.
vertex.
Okay.
Well, so maybe this should be atom add. I don't know. Add atom seems more natural in this case. But you understand you're going to have ambiguity if you have a 2-argument. If you always have the 3-argument case, then the curried form, you see, canonicalize, how does this degenerate into 1? No, that can't be right. Come on, look. Modify molecule of molecule, canonicalize.
So I don't know. So the reason it seemed to work for me is that a non-curried form will always have a molecule as the first argument.
Yeah, all right. Although many of our other functions, the operator would come first. All right, okay. Do you think canonicalize is a clear enough name here? It's probably okay.
Right. I mean, as a standalone function, you would want to call it canonical molecule or something like that.
Right. Okay. Okay. So if I say, how do I make a blank molecule? If I just say molecule of nothing, blip. What do I do? How do I make a blank molecule?
So it would be 2 empty lists.
This like this?
Well, so an empty list of atoms and an empty list of bonds.
Okay.
I don't think it does anything at the moment. Should
it?
Okay.
Oh, I think it should. If you've got, given that you've got this whole add atom nonsense.
So
right?
should it format as a summary box or?
I think so.
Okay.
Just as an empty molecule, the unmolecule. I would think, because then what I want to do. Okay, so let's say I say. Okay, so what you're saying is if I say molecule, and then all I have here is a solitary oxygen, like that, or that, like this, and oh my gosh, it made itself into water even before I knew it.
Right. So the goal here is to
Boy, those protons really get around. Sorry, go on.
No. The goal is to return a useful molecule as often as possible.
Yeah, I understand. So if I were to put, just for fun, by the way, somebody should report, Manu, you're here. You can report the weight, the insertion cursor is still wrong here.
Okay.
The horizontal insertion cursor is now.
All right.
Now, why didn't that make ozone?
Because you would need to have the bonds in.
Oh, I see. Okay, fine. Okay. Renumber atoms. What the heck does that do?
So not useful in most situations, but occasionally you have two copies of the same molecule that you got from different sources, but they have their atoms in different orders.
Okay, but so you probably also want to support the case where that's a list of replacements.
That makes sense.
I won't even try and guess what this actually does. Well, perhaps I should. What is that doing? I mean, what does it do? Isn't it always an L or a D? What does it do?
So in this case, it would represent the racemic mixture or just an unspecified stereochemistry. Is what it.
How can we represent the mixture?
So as soon as it was out of my mouth, I knew it was wrong. No, it just represents unspecified stereochemistry.
The racemic mixture would be a bulk quantity, which we're not attempting to handle here. You could have, a D form and an L form, or an R and an S form present, the two of them together as a pair, but it's still not what one would call a racemic mixture.
Yeah, okay. What is this? So this is, what is this? Generates coordinates and returns a molecule with coordinates specified. What is this doing? Can you explain it?
Right. So you take a molecule where the atom coordinates are automatic. It returns a molecule with the automatic coordinates filled in.
Okay, I don't think that's. Why don't you call it set atom coordinates or something? Well, what is it? Where you give it the atom coordinates, right?
So you could also let's see. So this is the function that a user will use to generate new coordinates.
What do you mean by to generate?
So it calls the embedding algorithm and generates them from whole cloth.
So embed molecule is most definitely not the right name.
With graph, we have different methods to do a graph layout, which includes essentially, the embedding of the vertices in.
Right. I mean, I would have expected this would be an option to molecule that possibly we could redo by rewrapping molecule and so on.
So the fact is, it's going to have a lot of options, method options.
But right. But so why isn't this just something in molecule itself where it's deciding how to do this? I mean, in other words, it's got molecule. What is for graphs? What's the embedding option mechanism? Isn't there an embedding option?
Graph layout.
Arrow, whatever, right?
Yes.
Okay, so what I'm suggesting is that there's in the end, well, they're the atom coordinates. How do you specify the atom coordinates in a molecule?
Using the atom coordinates.
Okay, so why isn't it the case that this is atom coordinates, that redoing the atom coordinates is just molecule with atom coordinates arrow and then something which says, automatic or whatever that redoes them? Do you get what I'm saying?
So let's see. So normally it says automatic, and then there would be something else that says fill in or something, right?
What does fill in mean? What do you mean by fill in?
as in, let's see, calculate them at the time that we are entering the expression. Like, calculate them ahead of time and store them in the expression.
I understand. So calculate now and return in that molecule instead of automatic. I mean, we could have a string there, atom coordinates, arrow, stored or something. I don't know what you want there. Or that could be something which is a whole elaborate association that specifies what to do to compute the atom coordinates.
Right. Okay, but I really feel like for a lot of chemists, this is going to be some of the.
By the way, you're getting hard to hear. Can you get closer to your?
Yeah. So I feel like for a lot of chemists that this is going to be one of the most important functions to them, and I want to
Why? Why? What is it doing?
So it's generating structures from which you could then feed to your electronic structure calculation.
But I mean, we're doing that automatically, right? Why isn't that happening automatically? That's what molecule does.
It would provide a particular set of coordinates.
Okay, so what is the way to? This is also automatically generating coordinates. Yes or no?
Yes. So if you don't supply any options, then it will just generate them automatically.
Okay. So you're saying there are a bunch of options, which God knows whether this is an ambiguous syntax or not. There's a bunch of options to modify molecule, which are really options to set atom coordinates, right?
Right.
Or what is it really? Compute atom coordinates? Evaluate atom coordinates? I mean, because that's what it's doing here, right? Yes?
Right. So the name embed molecule.
It's not going to happen.
Some, okay.
Yeah.
But that would have some cachet with chemists.
I don't care.
Okay.
It's extremely obscure.
It's really mostly only used for distance geometry for the embedding, and that's the default method in the library. There are other ways of generating sets of coordinates for molecules as well that are not the same, and they are not necessarily an embedding process.
Okay, you know what? If this is a specific way of setting coordinates that you want to put in here, we should do that. But embed molecule doesn't cut it. Because to me, embed molecule means stick the molecule in something else.
Right. I agree with you. I'm just
so if this is a specific method, if this wants to be, recompute the atom coordinates with some specific method, let's name it that way. If you want this to be a general way of computing atom coordinates that can support many methods, presumably those many methods could also be supported directly in the molecule object itself, then let's do that. But let's decide what it is.
So if it's the molecule object itself, the molecule, the head molecule could take a molecule as an argument, like graph can. And then we would have an option that says to do something to the molecule. For example, an option that would redefine what the coordinates were.
Just 1 second.
Right?
Just 1 second. I'm sorry. Sorry, go ahead. Yep.
Right. So I like compute atom coordinates either as a function on its own or as a modify molecule.
It should be modify molecule.
Okay. And so then there are some named methods that in the documentation page we would point to the publication where those come from.
No, but who cares? How are you going to specify them? You would then be saying, but in the molecule itself, before you modify anything, you've got to have a way of computing the atom coordinates, right? In the molecule.
So if in the molecule its atom coordinates goes to automatic and you feed this to compute atom coordinates.
No, I understand, but if in the molecule itself you want to specify which method you are using, there has to be a way to do that.
Right. So you could do atom coordinates goes to, and then a string or a list of rules that are the options for.
Well, you'd have to give some association, I think, for that. I mean, so in this case, then, what you're suggesting that you do is modify molecule of molecule, comma, and then you say compute atom coordinates. Yeah, that's okay. That's okay. That's okay. So then and the third thing would be either automatic, whatever the string the method is, right?
Right.
Or is it reset atom coordinates? Which is it?
I like compute because it specifically points out that it's a non-trivial task.
Okay, fine. All right. Okay, terrific. Energy. What the heck? What is this?
So this uses the force field to find the local.
Okay, so this is in fact compute atom coordinates again, but with a different method, right?
Right. So set compute atom coordinates doesn't by default minimize the energy because a user might want to have a diversity of conformations. But so we could make minimize an option to compute atom coordinates and combine the two.
Well, I say compute atom coordinates, and then the method is energy minimization. But I don't understand. Energy minimization, like for a protein or something, is super difficult, right? So people don't actually do it.
So for a protein, it might take a considerable amount of time, but for a smaller molecule like the kind there, it's not.
Okay, so then this could be a method for compute atom coordinates, but is it a thing you do very often?
So I think it would be something that users might do, and some users might.
Okay, well, fine. So it needs a name, but it's got to be a name that is about. It can't be energy minimized because that modify molecule. What the heck? I mean, what would it be? I mean, what would be the right thing to say? It would be something like.
So force field minimize, something to point out that it's using a force field.
It is giving it a new set of coordinates.
I know it is.
Like the others, so it should follow that same type of specification.
Yeah, I know. So I don't understand how it does that. Yeah.
And the method would be instead of creating them de novo by some particular method, some methods would take existing coordinates and then subject them to an energy minimization, for example, or something else to change the geometry.
Okay, so how about energy minimize atom coordinates?
I would have thought it would have been something more like, modify coordinates, whatever we're going to call that, and then the particular method is energy minimize, or
okay, well, that's fine. I mean that will work fine. If you're prepared to have that there, then this would become just purely this energy minimize.
So I actually like to keep these separate just because, let's see, so with the force field minimizing, eventually we're going to have nice syntax for adding constraints. So I want the bond angle between atoms 3, 6, and 7 to be 30 degrees, or I want it to be 120 degrees. And
all right, look, maybe we just say modify molecule energy minimize. Energy minimize configuration or something.
this is kind of like the spring electrical embedding for a graph, and there are a number of sub options there that can control that in terms of setting spring force constants and so on.
Well, how is it done for a graph?
I don't remember the details. I have not
Charles
actually
does.
used it.
So Charles, speak up, please.
Well, it's through sub options.
Of a method of a graph layout, and then it's sub options of graph layout. Is that right?
Yes.
Yeah, and I would expect this would be something similar. Is to supply the method options, which could include the constraints. That
okay. So what do you think this should be called? Okay. So we're saying compute atom coordinates using some random method, and then this is.
Why not just energy minimize atom coordinates? It's verbose, but
Well, that's what I was suggesting.
Yeah.
It's fine. Fine with me. And this would be equivalent. Is that correct?
Okay. Yeah. Yeah.
Yeah.
Okay.
And the second one would be a shortcut.
Yep. Okay. Continuing. Sorry, I'm going to run out of time. That's why I'm being more huffy here. Okay. And this is going to look like molecule pattern blah arrow blah. Is that correct?
Yeah.
Magnificent. Okay. The heck is that?
So replace substructure if it finds multiple instances of the substructure on the left.
Or replace with the same thing.
Yeah. But here it does them one by one.
Pretty weird. Which is the more common case to want? Well, this one is kind of a crapshoot, right? Because you don't actually know which order the molecule pattern is going to come out in.
Right, and to be honest, I'm not sure what is going to be the most common case. I'm really curious to get feedback from the users about which they like and which they find confusing.
Sorry, was there an answer to what order they come out in?
I don't think it really matters. Replace list returns a list of the different replacements, and that order may be deterministic, but it's not always obvious what it is.
Yeah, I understand.
So here it will return them in the same order that the substructure match would, or yeah. So it should return them in the same order as the substructure.
Wait a minute.
Yeah,
we called that molecule substructure, didn't we?
Right. So molecule substructure with atom indices, that's the same order that the molecules will come out in.
But now wait a minute. If there's a multiple match here, it's going to give a list of molecule. In that case, it's going to give a list of fragments. Is that correct? If Pat matches in multiple places, it gives a list of fragments, correct?
Yeah. Although, I mean, now that I'm thinking about it, I mean, it would be a list of practically identical things, unless the patterns were non-specific. So,
yeah, it could be completely different. I mean, they could be identical or they could be different.
Right.
I mean, if you ask for all of these rings, it's the cases case, so to speak. Right? So if there's a single one that matches, I mean, listen, this isn't very exciting. If you give a literal for Pat here, this is just going to return itself. Right? It's just going to return Pat.
Assuming Pat is found within mol.
Actually, it's not just going to return Pat. It's going to return Pat as a molecule.
Right.
Right.
So that brings up an interesting point that if it just finds the pattern once, it would be returning a single molecule, but if it finds it multiple times, it would return a list, and that's
of molecules.
I mean, isn't it problem?
No, wait. A list of molecules, right?
Yes.
I don't think that's hugely problematic. Well, I'm not certain. We might want to always return a list. I'm not sure. No, I don't think we need to.
I think it's better to always return a list.
So the normal way of dealing with that would be to have the third argument where you can specify a number of to return.
Yeah, except that you've just blown that by having this.
Right.
Although you could have a fourth argument, I suppose. And you could sort of have it as a courtesy support the third argument being that number. Yeah, but that's still, even if it's a singleton, it's going to be a single length list.
Yes, that's what the other functions do.
Yeah, I mean, okay, I think it wouldn't be bad to have an N there, because otherwise you get in some situation where you're finding 700 different, if you say find me, well, I don't know. Maybe these molecules aren't big enough that it matters, are they? I'm worrying about some kind of combinatorial explosion, but maybe that won't happen.
No, I imagine our users will try and make huge molecules and do this. and so that's not a bad idea.
Yeah.
Okay. All right, but then molecule substructure is the thing that returns the matched object. So then if you wanted to know what gets replaced, I don't really know why this isn't just saying why you don't extract the molecule substructure first and then simply give a bunch of, instead of molecule patterns, just molecule, blah, arrow, blah. You get what I'm saying? So in other words, the output from molecule substructure, which gives you a bunch of molecule objects, you should be able to say, replace in the molecule those raw molecule objects, not molecule patterns, the raw molecule objects with other molecule objects.
So that brings up an interesting point about treating instantiated molecules as patterns. Do we by default remove the hydrogens before searching for them, before treating them as patterns?
I don't know. I don't know anything about chemistry.
Right. No, so that's something that
Yeah.
Bob and I were talking about, and we didn't come up with a.
I would think you do remove the hydrogens since these protons seem to get around as we've been discussing.
Yeah. And the other thing, Stephen, your proposal about having a list of molecules that you would be using to be replaced, the left-hand sides would still map not to the specific instance that they had come from, but to the other instances as well.
No, that's not true. If it's a single molecule, it's got actual, if it's an actual molecule thing there, it's got actual atom indices in it. And that's,
but our matching isn't using those indices.
Well, then it's probably not the right, then no, but then you've got two cases that you need to consider.
Okay.
You've got the case of matching a molecule pattern in which the indices are nothing, they're dead meat. Right.
Right.
And the same thing's going to happen with a graph. Okay. So in a graph, if you've got something with raw indices that say take indices 11, 14, and 17 and blow them away and replace them by this, that's one thing to do. The other is take this subgraph independent of its indices and by graph isomorphism, figure out where it is and replace it.
Yes. Okay. And it's the same thing in chemistry. So
right. Okay. So what I'm suggesting is that if you have a molecule on the left-hand side that has raw atom indices, right, in it, and presumably those atom indices don't have to start at 1 and so on. They are whatever you got from molecule substructure.
Correct.
I'm saying
whoa. So for a molecule, for any given molecule, the atom indices always start at 1. If they don't, then we need some way of specifying that. Like,
that's what I thought I was going to. That's what I thought I just detected. So when you do molecule substructure, okay, the question is, does the thing extract? It's going to need to know that this was, in other words, I think the two cases, molecule pattern is the one that recanonicalizes and does essentially subgraph isomorphism. But yeah, but molecule itself should not recanonicalize. And perhaps the wrapper molecule pattern of molecule should recanonicalize.
So hold on though. A molecule that gets returned by modify molecule or molecule substructure has no idea of where it was before. It's a fresh molecule.
I understand that. Oh, wait a minute. Molecule substructure, I don't understand. That doesn't make sense to me. Molecule substructure, it seems to me. Okay, so that molecule fragment is context free, so to speak. Is that right?
Yes.
Yeah, that's not the case with our graph.
Right. I mean, but since the beginning, that's been the distinction between the molecule and the graph. Is in the molecule, the atoms are
recanonicalized. They relabel themselves.
Well, I mean, they didn't have any labels to start with. They were just a list, and they're only identified by their.
Well, they're not just a list. They have position. They have indices because you use them in the bond specifications and things. Okay, but so what we're saying.
Hold on, just so you know, the graph, even if you use integers for your vertices, those may not, in fact, coincide with the indices.
Exactly.
So just so you understand.
Yep.
No, they don't. They are always canonicalized. They always, the indices. are canonical.
Okay.
So what you put in, even if you happen to use integers, we treat them as labels, as the expression, there could be any expression.
Yeah, right.
Integers are not special.
Okay, but let's come back to this case, okay? Because what we're doing is, if I say, I want this particular piece of substructure to be replaced by this, okay? It's kind of bad that we don't have the pipeline that you say, I mean, look, in an expression, what you would be doing is you would be saying position of blah. The problem is that position and cases have been conflated into one function here. Right? So in the other case, we would say position of blah. I mean, so maybe what it is that we want molecule substructure's third argument to allow something that gives you these contextualized molecules somehow.
I see a use for this. This is, you're right, Stephen. We want specifically atoms 4, 8, and 12 or whatever.
But in the new molecule they come out in, those will be atoms 1, 2, and 3.
Well, I think we need a way to support what Stephen wants to do.
Okay, which is like giving tags to them or something that survives.
Yeah, I mean, if those atoms had names attached to them, those names would survive, right, Jason?
Maybe I don't know. So ideally, I'm not entirely certain that they should in general.
I think they should. As a molecular modeler, I would expect names that I've assigned to an atom. If I pull them out of a molecule as part of a substructure, I would expect those names to survive unless I told them to be replaced or regenerated de novo.
Okay, so the 0th order, like for first release, they are not kept.
Okay, so listen, this is welcome to the world of annotation calculus, this new field that we're in the process of inventing. This is an example of that issue.
That was already invented in version 9.
Which? This question of whether you carry things along. How do you deal with it for graphs?
Oh.
No, I mean the annotation calculus as in, when do you decide how you propagate the annotation? Do you carry it along or not?
Right.
Yes, it was done partially in version 9.
Okay, well, good. Okay, but back here, okay, so what we've identified is that there's an issue that we probably want a special third argument for molecule substructure that returns a thing that is a contextualized molecular fragment. Am I making sense? And my guess is the way that will work is that the molecule itself will accept some additional thing that gives some kind of mapping or something, just like it has atom coordinates, okay, which are an arbitrary, the coordinates. Yeah, here's a way to think about it, okay. You have these atom coordinates, but they're very arbitrary in the sense that this molecule could flip around in 3D space and so on and have different coordinates. Am I making sense? So my claim is, just like you have an embedding of the molecule in 3D coordinate space, so similarly you have an embedding in molecule in molecular index space. And that's another kind of arbitrary thing that you might want to give as an advisory feature of the molecule. Did that make any sense?
I think I understand what you want there.
Jason, did that make sense to you?
Right, so that you can supply your own indices to the
exactly, just as you can supply your own coordinates.
Yeah.
Right. I think that's the right way to think about it. And then we're not going to get it for this version, but that's probably the right thing to do. So in other words, when we say molecule substructure, we would say the default for molecule substructure would just be to return the substructure, but we want to have a case of that says, wherever it was, I lost it here. Here we go. Molecule substructure. So what I'm suggesting here is let's say something like molecule relative. That's not the right term. But embedded. Something like embedded, that's not the right term either.
And well, context, there's the language context structure that we already have. That's going to lead to confusion.
Wait,
yeah.
I don't know. I think the word contextualize wouldn't be confused with context.
But how are you going to know that it's different from the namespace context? It's been around since.
Yeah, but contextualize is a different word. This is not the right term. Neither of these are the right terms, but something like this is what we want. And then the question is what the I mean, actually, this might be better as something like molecular fragment. That might be the right term for it.
Right, and so I hesitate to use molecule fragment or molecule substructure at the moment because I don't know. I envision there being a head for this thing, for a molecule that is a fragment that has unfinished bonds. For this.
Okay, we're not going to solve this problem right now. Okay, but this is, I think we've identified a relevant, a good direction to go, and I don't think with the design we have right now is going to cut anything off. Okay. Set bond length. Okay, set bond angle. That takes a triple. Yeah, okay. Fine. Okay, chemical bond Q.
Right, and so this is just a utility to tell you, are these two bonded or not?
But wouldn't you want to compute the chemical bond type? How would you find the chemical bond type?
So you could use bond list on M, and then let's see, so you would do bond list M, and then the second argument as of right now, it would be underscore 18, 3, and so it would return anything in the list of bonds that matches that.
What? Underscore, what are you saying? Bond list, chemical bond list. Of M, comma what?
So
comma blank, comma 18.3?
No, so blank is the head in that case. So right now.
Weird. No, that's just wrong. That I know, because you've got single bond, double bond as okay, so what are you going to do in the real case here?
So it would be chemical bond 18, 3.
This, like this.
No, with a head chemical bond.
So
that doesn't make sense to me. This doesn't make sense. This just doesn't make sense.
3 and then underscore.
Yeah, that doesn't make sense. There's no reason to do it that way.
Actually, that's almost like using cases.
Yeah, why not just use cases?
Well, it's very much like edge list. Edge list takes a pattern in the second argument.
So I don't think this is the right way to do it. I mean, I think, okay, so this question about, is it bonded, right?
Mm-hmm.
Why isn't that the same story as chemical bond list? That is, if the bond list is empty, this is either going to return a bond or it's going to return nothing, right?
Right. So bond Q in this case just checks is that list empty.
Right, but why do we need that as a separate function? Is it really that common?
I think it's fairly common to ask, is there a bond between atoms X and Y?
Is that right? Bob, do you want to comment on that?
Yeah, that would be something that would be very useful to have.
All right, okay, fine. But do you not want to know what type of a bond it is?
Sometimes you want to know that as well, depending on what you're trying to do.
But it's useful to have a function that is true or false that you can have in a pattern test, that kind of thing.
What if we just ask for the bond type and it returns single bond, double bond, triple bond, or missing,
Yeah, he wants
not missing, not available, but missing, not present, or something.
I'm personally using in my code a lot of places this a condition on the bond.
Right. So okay. So fine. So this is a chemical bond that would say, is there a single bond between those things? Does that make sense?
Yeah, absolutely. And if you
Okay.
omit the third argument,
Then it'll give you any bond.
okay, yeah.
Okay. So this case of chemical bond list. Okay. This doesn't make sense to me. This is asking. So for example, a typical thing I might want is a list. So chemical bond list of M just gives all of the list, all of the bonds, right?
Yes.
Correct? Yes, is that correct? Okay.
Yes.
So then if I want bonds with tungsten atoms, well, okay, so that's single, but if I want bonds between tungsten atoms and something else, how would I get that?
So you would type chemical bond list M, chemical bond, and then in place of one of the indices, you would put a W, and in the other, for the other index, you would put an underscore. So I suppose you could omit the chemical bond now that we don't have single bond, double bond, triple bond,
Yeah.
aromatic bond.
Well, then what we'd end up with is, is something where we're saying, something like this, comma, single might be the reasonable way to do it. Is that right?
Right. Yeah. So atom list, though, is a 2-argument form rather than a 3-argument, because in an atom list, so you give it some type of atom pattern as the second argument, and you can make that into a rule if you want to access atom properties.
And are you doing that with chemical bond as well?
So I don't have bond properties set up right now, but I want to.
Okay, but so that would end up being something where rather bizarrely, it would look like this.
Yeah, that's weird.
All right, I am going to have to go very, very soon. So I just want to have a quick look through these other things. So provisionally, I think this is going to make sense, but I think we need to be careful about it. And maybe this is an alternative form. If every bond, oh boy, I was going to say have triples with the bond in them, but that's silly. It's horrible. Okay. I think this is a big deal, right?
Right. Molecule equal is not a trivial function. But here I'm showing that if you just create a cyclohexanol and then you grab the cyclohexanol from our knowledge base, the two are obviously not same Q.
Although they probably should be.
I mean, so the data in our knowledge base, the atom order and everything, that's not something I can, yeah, it's not something I control at the moment. I could reorder them canonical.
Well, we should redo that. I mean, we should do it so that yeah, I think we should do it so that they come back the same. But okay, so molecule equal, fantastic. I mean, that seems like a great thing to have. And presumably it's the case that if I say molecule modify, oops, it's modify molecule, isn't it?
Yes.
Maybe we should call it molecule modify. I think we should call it molecule modify.
Okay. Yeah, I mean, yeah.
Okay, so anyway, I do molecule modify, canonicalize to both of these, then they will be same Q, correct?
They really should be.
Okay. Molecule contains Q we talked about.
So since the molecule structure allows disconnected components.
Oh boy, this business about keeping coordinates, my friend, okay? You are being totally inconsistent, right? If you keep coordinates so that your molecules fit together like a nice set of puzzle pieces, but you don't keep indices, you recanonicalize the indices, what is going on? Do you get what I'm saying?
Yep.
So I don't see the distinction there. I
Okay, because you can recenter the molecule on its center of mass.
mean,
Okay, and which means you're recanonicalizing the coordinates, so to speak. You take a fragment from the molecule, you recanonicalize the coordinates, but yet you are choosing not to do that, but you're choosing to recanonicalize in atom index space. You're not recanonicalizing in physical space, but you are recanonicalizing in atom index space. Do you get what I'm saying? So you obviously want in molecule modify, you obviously want something that essentially recenters the molecule. Do you get what I'm saying?
okay, yeah.
But that shouldn't always happen.
Well, I don't know. You tell me. I mean,
No, it shouldn't. If you're changing just a bond length, you would expect part of the molecule to stay fixed wherever the coordinates were.
okay, fine. But then what is happening then in these functions, molecule substructure? Okay, so what we've agreed is molecule substructure needs the two cases, and maybe they'll end up as an option in the end. The two cases of, okay, so there are actually four cases, right? There's, do you recenter the coordinates and potentially re-rotate the thing, right, to some canonical rotation? And do you, and I want to talk about canonical rotation in a second, and do you recanonicalize the atom indices? Am I making sense?
Yes, they're all of those variations.
Okay, so those are probably going to need to be options in molecule substructure, I think.
Yep, and we just have to find a reasonable default behavior.
Right, which I think you are arguing is redo the atom indices, don't redo the coordinates, the physical coordinates. Okay,
So,
can I
okay, go ahead. Yeah.
can I talk about the orientation of molecules? How do you determine the canonical orientation for a molecule?
So we find the primary moments and align those with the.
What happens if there's degenerate moments? There aren't, because the masses of isotopes are non-commensurate in some weird way.
So you can have a linear molecule.
Sure, but then it doesn't matter, right?
Right.
But I'm saying there's no degeneracy. If the masses of isotopes were integers, there could be degeneracies, I claim. But the chance of, it's like a hash code, the chance of a degeneracy is extremely low.
But I don't think chemists usually worry about that. They would expect benzene to be degenerate.
No. I'm saying the following point. I'm saying there could be two. If you are orienting the molecule using the principal moments of inertia, right?
Right.
Then it could be the case that there are a molecule. What am I saying? That has where you can't. Am I right? Where you have
two canonical or perhaps more canonical forms that it would come to.
Yeah, that's right. But I think there probably can't be in this case. Okay. So connected molecular components. Seems okay. Connected molecule. Oh my gosh. This is sliding down the slippery slope of what is a molecule. And is sodium chloride a molecule?
So it's a Wolfram Language molecule, but it would not be connected molecule Q. I mean, so this is a case where it would be fine. I would be more than happy to have connected graph Q overloaded on a molecule.
Yeah. Well, and connected components could be overloaded here as well.
Right, but that returns a list of indices.
Oh.
That's why you have.
But no, wait. But don't we have a way of finding? We do have a way for graphs. We added that recently. It's called graph components or something.
And that returns a list of graphs. So there's also connected components, which returns the lists of.
Okay, this is a little bit of a can of worms. This thing about connected molecules is a bit of a can of worms. I feel like those worms aren't. I'm not going to do them justice in these couple of minutes here.
Right. So this was just to briefly show that I implemented a style. Users adding their own styles here. So using the style wrapper on a pattern.
Style wrapper on a pattern. Where is that?
Right. So in the bottom one, you have a style 6-membered ring is defined as a molecule pattern up above. And here you're just saying that you want it to be this particular shade.
Wow, that's pretty space age. That's nice. I'm finally going to learn something about chemistry. This is exciting. This is actually easy enough to use that, you know. Okay, we have a question or comment from a live stream from Sander. If you have a CH3 tail that is connected to another carbon, how do you specify the rotation of that thing? Oh gosh.
Wait, so the torsion angle?
Yeah.
Right. So
Yeah.
so I'm not proposing it as a system symbol yet until probably the next version, but right now you can access it via the molecule value. So you would say you want the torsion angle between atoms 1, 2, 3, and 4.
Right, but so what he's pointing out is if you attach that tail somewhere, it is degenerate. The thing can spin around, right? In principle, when you attach it, or am I wrong?
No, you're right. It's not degenerate. It's unspecified.
Yeah, it's unspecified, and it might, but there's an energy minimization which would cause it to be a particular thing. So
that's true. You could do that. And there are some heuristic rules that could also be used to position it. And if you connected it to your molecule, I would expect that you would use the heuristic rules for the correct distance and angle to some other atom and torsion angle to yet a third atom 2 bonds away. That's what we would normally do.
So right now, when we combine molecules or change structures or whatnot, we generate new coordinates as if it were a whole new molecule.
right, okay, fair enough.
Because
no, it shouldn't supply a whole new set of coordinates.
Well, I mean, what you're talking about will take some time to implement, and it's not done yet. So
Okay.
it does now, as we've talked about.
Right. Okay. Spectacular stuff. A few loose ends, but we're getting really close here. And I think the next time around, we probably should see guide pages and so on. And I assume you guys are going to draft those, right?
Right.
We've been working on that. Yep.
Okay. It's very exciting functionality. Really exciting functionality, in my opinion. It's great. It's really, you know, it brings into the sort of easy computational domain a whole new range of things. And yeah, anyway, wonderful. All right. Okay. Thanks, everybody. And see you soon.
Thank you.
Okay.
Bye.
Bye-bye. Bye.